Hi, my name is Lisa Richter. I'm Director of Industry Outreach and Growth for CSIA. Welcome to the Masterclass. Before we get started, a quick word about CSIA. Probably most of you here today are familiar with the association, but if you are not, all you really need to know is that CSIA's mission is to help SIs build better businesses. How do we do that? Well, for starters, we have a team of volunteer SIs who have crowdsourced a best practices manual to help SIs scale their businesses. CSIA also offers a certification program and many other resources and benefits, including professional development, learning from your peers, and access to professional services experts, including insurance, financial, and legal, who understand the SI's unique business needs. For partner members, CSIA offers an ecosystem to grow your SI programs, understand your customers' pain points, monitor industry trends, and share your thought leadership. With thousands of qualified system integrators and suppliers, the CSIA Industrial Automation Exchange helps SIs, industry suppliers, and manufacturers connect to do business. For SIs and partners, it provides a platform to support your content and SEO marketing efforts, position yourself as a thought leader, and nurture prospects during their complicated buyer's journey. If you are currently not a member, now is a great time to join. Membership provides you and your entire team a full lineup of virtual events and other resources, from accounting to sales to operations, 365 days per year. Plus, being a CSIA member means you get special pricing for the CSIA Executive Conference in addition to other resources. If you are currently a member, thank you. I hope to see you in New Orleans, next couple weeks. One last housekeeping note before I turn it over to today's speaker. If you have any questions during the presentations, please use the Q&A feature in Zoom. That helps us stay organized. The session is being recorded, and you will get a link to the recording in the next day or so. At this time, I would like to turn it over to today's speaker. Xavier, take it away.
Good morning, and thank you. Just let me share my screen here. We'll get ourselves started. Everyone on the call, I'm Xavier Masrobian. I am the VP of Sales and Marketing here for Skynet. If you have any questions, do not hesitate to give us a call. My email is right up front, and I'll also present it at the back. But what I'd like to do today is we're going to talk about the 5 ways a smart MQTT broker helps ensure data consistency. And so just to bring this in context, we're going to be talking about smart message queuing, latest value, time order, connection status, and data security within our conversation. But before we get started to talk about why a smarter is better, we kind of have to do a reset. And then in that reset, what I'd like to do is we're going to do a quick overview on MQTT. So we're going to compare the MQTT protocols. So MQTT JSON, Sparkplug 2.2, Sparkplug 3. It used to be called Sparkplug B, but they've changed the numeric or the numbering system. So it's now 2.2 in version 3. And then we're going to get into why smarter is better. So let's talk about a typical architecture for MQTT JSON. We have a client, which is a publisher, that will publish data to a broker, and the broker being a message router. And then we have other clients that will subscribe to the broker or to the topics of the broker. Now, the connections are one-to-one to the broker. So my client is connecting to the broker one-to-one. In this particular case, I have a temperature sensor connected to the broker. I have the SCADA system connected to the broker, and data is one-to-many. So as I have more clients connected to the broker, I have more connections that can be shared, or topics that can be shared. Should a client disconnect? So if my sensor were to disconnect from the broker, there is a predefined last will and testament message that's published by the broker to a defined topic that basically includes the last message, in terms of the topic, the retained message flag, the quality of service, and the payload. Not complicated, but at the end of the day, that's how we communicate with JSON. When we talk about Sparkplug B, or now version 2.2, topology changes a bit. They now have this concept of an edge of network device, which is your publisher. We have our broker, which is still the message router. we have now a primary application. So this is the application in charge, if you wish, the best way to look at it. And then we have what's called non-primary applications. And so there can be limitless numbers of non-primary applications, but there could only be one primary application. So again, connections are one-to-one to the broker. So I have a temperature sensor, an edge of network device connected to the broker. I have my primary application SCADA, which is subscribing to that topic and getting the status of the temperature sensor. And then any backend systems would be connected as a non-primary application. Now, one of the advantages of Sparkplug B is that it is connection aware. If the client or the edge of network device, if it disconnects, the broker shares that connection status with any primary or non-primary application. So that's an advantage. We know right away what's happening to the connections. When we talk about Sparkplug version 3, and this is the latest specification that came out, I think it's in October or November of last year, things change again just a bit. We do have this concept of the edge of network device. We have the broker, but now we just have subscribers. And so they've eliminated the need for primary and non-primary applications. And in essence, everybody now is an application which is subscribing to the broker. The temperature sensor is still my edge of network device. And now my applications, I don't have this concept of non-primary and primary applications. Everyone's just an application on MQTT. Should the client disconnect? Everyone knows, because it is client aware. So the last will and testament message is strictly defined, and everyone knows that that client, in my case, the sensor, has disconnected from the broker. So there are some advantages of MQTT. And when we look at what's happening in industrial automation, we see a lot of implementations of MQTT, and this is predominantly why. It is a publish and subscribe messaging transport. And so what that means is that if I have a remote facility, such as a water facility, and I want to network that data to a central system, the good part is I don't need to have an open inbound firewall port on that control system. It's outbound published. The disadvantage is I need to have internet access to be able to publish, but we can talk a bit about that later. It's lightweight. So typically, once an MQTT client or edge of network is connected to the broker, every piece of data that's coming back to the broker is small because you're not having to publish the entire birth message. The first message that's published by the edge of network or the client includes its birth message, and that gives it everything on what it's tracking. And so that tends to be a larger payload typically, and it again depends on how you're implementing it in your architecture. It is scalable and scalable to a limit. And just want you to be aware that some of the protocols scale better than others within MQTT. They have some pluses and minuses, but it is typically scalable. It's also very battery friendly. So, when we're talking about small sensors out in the field, typically it's very well suited for low power devices. And so, excuse me, if you're looking at MQTT, it's a great protocol to get the remote sensors because you're not using a lot of energy to drive or to provide an update. So now let's talk a little bit about the disadvantages. And some of you who have worked with MQTT may have run into them. The first one is MQTT is a message protocol. It does not offer a standard data protocol. And so unless you're using Sparkplug or version 2.2 or version 3, what's happening is that every client can be publishing data in a different JSON schema or a JSON format. And so that tends to create a bit of a problem. The broker is really a relay. It's a message relay. So it doesn't know what is inside the message. Think of it as an envelope. The envelope comes into your sorting facility. We don't know what's in the envelope. We just know that there's an envelope. And the broker can't perform intelligent routing on the content of the message. One of the biggest issues with MQTT is message order. And so if you are using MQTT to log it into a historian or to move data to a historian or big data lake, and it's not critical that you know the exact last value of that item, then MQTT works great. But message order isn't maintained in the protocol, and that can pose a bit of a problem. There's no guaranteed consistency. I can have one client publishing faster than another. There's no consistency within the system because everyone's going into the same broker. Daisy chaining. So one of the challenges with MQTT is that it's nice to have a broker. I may have a broker sitting in my control network, and I want to bridge that data to a DMZ. Well, in order to do that, I'm now doing broker-to-broker communications. And understanding that in MQTT, you have this concept of quality of service. So inside the control network and outside the control network, having consistency within the quality of service can lead to message order, again, falling out of place. And so that creates a bit of a problem. It's also very difficult to restrict access on topics. Remember that the broker is just that, it's a relay. So it doesn't know what's in the message, and it doesn't know how to restrict messages inside the topics because frankly, it's just relaying the messages. So setting up something like read-only or a data subset is not something that the broker can do. The quality of service is a bit misleading. So there are 3 qualities of service within Sparkplug B, or within MQTT. 0, which is at most once, which means it's fire and forget. The client is going to fire into the broker and forget about it. We have at least once, so that doesn't prevent it from receiving the message twice. It just means that it's going to get it at least once and potentially twice. And then exactly once. So exactly once means that we're going to confirm that the broker received that message only once. Now, each one of these levels of service create more impact or more usage or performance impact on the broker. So where 0 has the least impact on the broker, using quality of service 2 will have the most impact on the performance of the broker because it's constantly sending messages back between the client and the broker to confirm that the message was received exactly once. With Sparkplug B, we're still riding on MQTT. So since we're riding on MQTT, we still have the same challenges of MQTT, which is we can't base or route messages based on packet content. Remember, the broker doesn't know what's in the message. Sparkplug B or 2.2 defines what's in the message, but the broker doesn't actually know what's in the message. It's just passing and routing the messages. There is no guarantee for message order again. Same applies. Daisy chaining is still applicable in Sparkplug 2.2 because we're dealing with broker-to-broker communications, and the underlying communications is still MQTT. It's difficult to restrict topics read-only on the data set, again, for the same reasons of whether it's JSON, MQTT JSON or 2.2, we still have the same restriction in terms of how we can make data points read-only or data subsets as read-only. There can only be one primary application. So why is that kind of important? So primary application is the one that defines I am the only one. I am the one that can communicate with the edge of network device and tell you to republish your birth message. So I'm the one that can communicate directly with the client or through the broker from the client. That can pose a bit of a problem because if you only have one and then you also have non-primary applications that can cause a little bit of difficulty, and we'll go through that in just a second. So the edge of network do not know if their messages are received. That's one of the challenges with 2.2. We also have this concept of the non-primary application. So they do not publish their state. And so why that's important is that the non-primary application basically says, hey, look, I am here and I'm collecting data, but if the non-primary application connects after the edge of network device, it'll never see the node until the node republishes as birth, and then lo and behold, it will now see that data. So that creates a bit of a problem with Sparkplug B. Again, edge of network cannot mark its data as read-only. Again, one of the restrictions within Sparkplug. And so you can see that there's some pluses and some minuses. So in order to address some of the pluses and minuses, the Eclipse Foundation released version 3.0. And so some of the things that it's corrected and some of the things it has not. So the first one is it hasn't changed the message routing. It doesn't guarantee message order because remember, all of this is still connected to MQTT as the protocol, and that protocol doesn't address these daisy chaining issues or the guaranteed message order. It's also difficult to restrict access to the topics. That still hasn't changed. The edge of network still doesn't know if the messages have been received. That hasn't changed, as well as the edge of networks node can't mark data as read-only. So again, version 3 doesn't address any of the core issues, but it does address the issue of the applications. So with version 3, we have applications connected to the broker. And then we have edge of network connected to the broker. Every time a new application connects to the broker, it sends out a message to all of the edge of network devices and says, hey, please publish your birth. And that's fine if you're dealing with 5, 10, maybe 15 connections. Remember, the birth message is the largest message in MQTT Sparkplug. And so you have an application that's joining and it says, please send me your birth message so that I can, identify the data and the data scheme that you've got and bring that into my application. Well, that's fine for a few applications. But if I have 10 applications and 100 remote connections, then all of a sudden I get what's called a birth storm. And that birth storm is all of the applications are requesting a birth. The edge of networks are publishing their birth message, and now the broker is being overwhelmed. And so this is a common trait. There's not much we can do about it. It's just part of the protocol. And it doesn't really create much of an issue unless you're dealing with lots and lots of edge of network devices and multiple applications onto the broker. So version 2.2 and version 3 are non-compatible. I mean, from a broker's perspective, you can have them both go in, but from the actual the capabilities, you can't have the benefits of 3 and the benefits of 2.2 running on the same broker because they just don't play together. So you make a decision as to which protocol you want to use. So now that we're on the same page, let's talk about why a smarter broker is better. So when we're operating, when an operator is monitoring an HMI or a SCADA system, they need to know exactly what's happening on the physical device. Data that's stale or out of correct or time sequence can lead to incorrect decisions, and any disconnects or network irregularities must be known. So the simple way of looking at it is if I am monitoring water and wastewater facilities, I need to know that the levels are fine, the pumps are running, and I've got no alarms and events that are taking place along my network. And so at the end of the day, it's kind of important to know exactly what's happening. So to ensure data consistency, we really need to have smart message queuing. So what does that really mean? So message queuing is needed in real-time systems to handle message overload. At the end of the day, a broker will get overloaded if the producer, the edge of network devices, send data faster than the consumer can receive it. And so in a situation like that, you can have a chronic overload that requires the broker to drop messages. If the broker is overwhelmed, it will start to randomly drop messages. And so that can create a bit of a problem because now my last known value may not be in sync. A smart broker can implement an intelligent message queuing that examines the message content and ensures that the latest value of every data item is delivered, even when earlier values are dropped. And that's really important so that from an HMI or a monitoring perspective, I know that I'm always working from the latest value. It keeps the data at the consumer consistent with the physical reality of the producer, and that's very important. But to ensure the latest value, MQTT doesn't guarantee message order, and it can drop the messages, whereas a smart broker with message queuing ensures that the latest value is always gets delivered. And that's the key component, because if I'm working with multiple messages, multiple topics, it's not uncommon for the broker to be overwhelmed. Time order. To ensure data consistency, I need time order. Time order is preserved in a single message topic, but it's not necessarily among multiple topics. And so the more topics you have, the more time order can be affected. A smart broker can preserve the time order as it converts the message to other protocols. So, having the data in MQTT is fantastic, but I may need to get that data to an MES system. I may need to get it to a scheduling system, and it's going to require a different protocol. So MQTT may not be the choice. I may be using collecting via Sparkplug B, but delivering that message into OPC UA or into ODBC or into some other protocol. And so having the ability to preserve time order keeps everyone in sync on the data. Connection status. As I mentioned earlier, JSON scheme or MQTT JSON doesn't propagate a connection status. It does, to a sense that it tells the broker will publish a last will and testament message, but that last will and testament message is sent to a different topic in the broker. And so if you're using JSON, you have to manually align the last will and testament message with the data. And that's a programming issue, requires more implementation, if you will. With a smart broker, the connection status can be applied to each data point that's associated with a connection. So whether we're using MQTT JSON or JSON schema, we always know what the connection status of every data point associated with that connection. Data security. Now, one of the benefits of MQTT is its ability to publish outbound. And so if I am moving data from a control network, or if I'm collecting from devices within my control network, I don't have to open up a whole bunch of inbound firewall ports on all of those devices. Where the challenge comes in, though, is if I want to bridge the broker from the control zone to the DMZ or to the corporate network. So experts around the world, and in fact, we've seen it in the US, we've seen it in Europe, we've seen it in China. Everyone is proposing that you follow NIST document SP 800-82, which really ensures that there's no link direct link, if you will, between the corporate networks and the control networks. And to do that, you need to have a DMZ, something in the middle that prevents the networks from being connected, but allows the data to be published or moved across. To do this, you need to then bridge your brokers. Well, when we talked earlier about bridging brokers, we have this issue of quality of service. So if we are bridging the quality of service, as an example, inside my control network, I'm using quality of service 2. If I want to use quality of service 2 in the DMZ, now I've got to bridge quality of service across these two brokers. That tends to be problematic because the more brokers and connections between brokers I have, the more likely my data is going to fall out of order because of the network traffic between the brokers and the clients. And so, the key is that this becomes a bit of a challenge. It's not undoable. It just means that I'm more likely to have more edge cases. That multi-hopping or daisy chaining requires you to be able to have 2 or more servers connected. And that's where a challenge becomes. Now, a smart broker will allow you to daisy chain across a DMZ. And that's the key, is that I can now bridge the data between the control zone and the corporate network. So how we ensure that is we don't use MQTT for that bridging, we mirror the data. And by mirroring the data, we're still getting the outbound connection and we're still getting bidirectional, but whatever happens on this broker is immediately available on this one. So a little bit about us. We have over 27,000 installations in 86 countries. We have not, so we've been working with the Eclipse Foundation. Very shortly, we'll be joining the foundation. We are used by 10 of the top 10 automation providers worldwide. We have OEM relationships with hardware and software providers, and we're an Aviva, certified Aviva technology partner. More importantly, you'll find our applications pretty much everywhere where you're moving data in real time. You need to aggregate, you need to network, you need to connect to other protocols. The Data Hub is a perfect solution for that. So to finish off, I'd like to thank you for your time. You can visit our website at cogentdatahub.com. You can download the white paper and you'll get a copy of the link shortly. You can also read about the Smart Broker directly on our website. Download the Data Hub. And if you're in New Orleans, which I hope many of you will be, because we are a sponsor of New Orleans, we love the CSIA. We are actually going to be showing a first look at version 11. And version 11 is our next product, which is due out for release in December. There's some exciting new features that are coming in version 11. So stop by our booth, come see us. Contact us directly. There's my email address. If you have any sales questions, reach out to sales, reach out to support. You just have to remember sales at Skynet or support at Skynet, and we'll be able to answer your questions whenever we can. So thank you.
Yeah, so we do have some questions if you're ready for that. First question is, and forgive me because I don't know the terminology all that well, but in EON devices, Rockwell, that don't have MQTT natively available, is the principle to just push OPC gateway as close to edge as possible?
That is, so there's a couple of ways that one can do it. So in the case of Rockwell, if it doesn't support MQTT natively, you can actually use a gateway or use a Data Hub gateway. We support that, that will actually connect to OPC. And publish the data in any flavor of MQTT you want, whether that's JSON, JSON schema, or Sparkplug B, and then it can then be ingested by the broker, and then any topic can be then published to your SCADA system if you want. The other option is you could use OPC as the, OPC UA as the network, but again, the challenge here is that the OPC UA requires that inbound firewall port. So you really do want to use a publish and subscribe if it's remote. But yes, you could publish from OPC directly to MQTT Sparkplug if you wanted. It will maintain the data, the namespace. So all the namespace of the device will be carried through in that message.
Does the Data Hub MQTT broker have a built-in rules engine that facilitates data processing by enabling users to create data-driven rules on the broker and to send the results to a data integration solution?
So the short answer is yes. The long answer is that Data Hub actually has a built-in scripting language that supports a complex time and event-based processing on any value that arrives from any interface. So regardless of whether it's MQTT or OPC UA or OPC DA or Modbus, we can synthesize new data points and topics, which can then be passed to any system by any supported interface.
Why is daisy chaining MQTT brokers unreliable?
It comes down to the amount of messages the broker has to deal with. And so as I talked earlier, the more topics you have, the more edge of network devices you have, or the more clients you have, the more the broker is being taxed. And so when you're bridging the brokers, now I've got a lot of cross messaging running between the brokers, and I've got cross messaging running between the clients. And so it becomes more complex to keep messages in order. And so what we have found is most of the clients that are looking to bridge a broker from a control network to a DMZ, or from DMZ to control network, they will use a different protocol mirroring the data between the two so that the data stays consistent and you're not having to bridge that quality of service issue between the two brokers.
What happens if the MQTT client disconnects from the MQTT broker with Sparkplug B? Does the broker support store and forward?
So store and forward is a function of the client. And so a simple way of looking at this is that if I have a client that disconnects to the broker, many MQTT broker or clients will actually support store and forward. Now, when the connection's reestablished, the message header will identify whether it's historical information or whether it's real-time information. Remember, the broker, a traditional broker, does not, it doesn't know what's in the information, but it will know that it's historical versus non-historical. And if you follow the specification, there shouldn't be any issues. What challenges you have is when you have both historical and real-time data running across the same channel. As long as the application, primary application, can decipher between the two of them, there's no issue. In the case of the data hub, we do support store and forward to the broker. And how we do that is we decipher the messages coming in, we publish them to a purpose-built historian, and then we retransmit them to the primary application, if you will. And so that is possible.
Is MQTT the only secure way to move industrial data to the cloud? Do I need an on-premises broker?
So the answer to that question is architectural again, but the answer is many cloud systems support other connections outside of MQTT. So any publish or subscribe protocol will, typically depends on the broker that you're using. It seems that MQTT is the most common one, but the truth is that if you take a look at the specifications for Microsoft or AWS, they offer REST interfaces. They also offer MQTT. And at the end of the day, they've actually created their own custom versions to make it work. It is, you don't require an on-premise broker. That's not important. If you can get data from the edge of network device to the internet connectivity, then you don't need a broker in-house. You could just use a broker in the cloud.
Can broker upgrades be performed with zero downtime?
That too also depends on your architecture. If the broker is not redundant, the answer is no, because how do you update an application if everyone's connecting to the same application? But if you are running a redundant set of brokers, the answer is absolutely. You can, in fact, upgrade one while you run data to the other one. Your application, your primary application, or your application, if you will, would need to be able to decipher between the two of them as to which is primary, which is secondary, or we'll have to decipher the managed redundancy. And if that can't be happened, the data hub can also manage redundancy for you between the two. And we would highly recommend, if it's a critical application, to use redundant brokers.
Can the data hub broker act as a standard MQTT broker without processing the data?
Yeah, absolutely. So we can be a standard broker as well as, we can be a standard broker or we can be a smart broker. But I can only I make a decision as to which way I want to go. I can either be a standard broker and I don't process messages, or I can be a smart broker where I'll process messages. I can't have some connections pre-processed and some not.
The data had processed different streams of MQTT, MQTT JSON, and Sparkplug at the same time.
The answer is yes. The Data Hub can process any incoming MQTT message. So whether that's JSON, whether that's Sparkplug, whether that's JSON schema, I can have multiple different JSON formats coming in, and the Data Hub can automatically parse those messages and deliver them to whichever protocol you want. So as an example, we have implementations where customers are bringing in JSON schema or JSON and JSON schema, and then they're publishing that data to MQTT Sparkplug B. Not a problem, piece of cake.
Okay, final question. Does the Data Hub broker support unified namespace?
So unified namespace is a new buzzword that's been wrapped around or put out. The fact is the Data Hub maintains the namespace of all connecting clients. We actually, regardless of the protocol used, whether you're using OPC UA, OPC DA, or Modbus or ODBC, we maintain a unified namespace. And so that same namespace is what's used with MQTT or MQTT Sparkplug. And so we've been doing it for 25 years. And at the end of the day, it's the same as what everybody talks about as unified namespace. The advantage of unified namespace is that it allows you to connect more freely to other systems, whether they're MES systems or whether they're scheduling systems or maintenance systems. And so that's really what the value is having a central repository, not even a repository, but a real-time repository to connect to other systems, bidirectionally for that matter.
Okay, well, thank you. Thank you for that presentation. I've got a couple slides that hopefully Holly can pull up for me as I wrap up the event today. On behalf of CSIA, I would like to thank our speaker for this informative discussion, and also thank you to Skynet for sponsoring the event. And of course, thank you for attending. Be sure to bookmark the CSIA events calendar so you don't miss any upcoming events. And that's a wrap. Once again, thank you for joining us and have a great day.
Thank you.